What's up, guys? Dylan here, and welcome to day 12 of Advent of Code 2020. And before we get started here, I want to mention that I will be providing my code now down with a link in the description below to GitHub, so you guys can download my code and check it out. And once again, I'm sorry that I've been consistent on posting on time the last couple days. I'm getting through my college finals, but I think we're good to go now. So let's go ahead and get into day 12 here. So, all right, rain risk. The ferry needs to take evasive actions, navigation, instructions. North means move north, south means move south, and so on. Forward means go the direction that we're facing, and we start facing, we always start by facing east, and left and right change the direction of the ship. Okay, so let's go ahead and get our puzzle input. So let's go ahead and copy that over into VS Code here, and let's get into the solution. So first off, of course, with open, if I can type, file, man, I'm tired today. Input12.txt as a file, and data, of course, like always, is going to equal file.readLines, and data then will be equal to line.strip for line in data. Okay, so def, we'll call it get displacement today. Get displacement, and we're going to give it an initial position of our ship. X and Y is equal to 0. And what are we even checking for again? What is the Manhattan distance? Okay, so basically the absolute value of X plus the absolute value of Y. Okay. That's what I figured. And then we need to know what direction the ship is facing, but it's going to have to rotate. So, well, we'll just say direction is equal to east for now. And then we'll say for line in data, command and value are going to be equal to line 0. And then the value should always be a number. So we're going to say, and then int line, and from 1 to the end, because we don't know how many characters will be in there. And then we'll say, we got some drudgery here. So if command is equal to north, if command is, what am I saying? Yeah, if command is equal to north, then we'll say y plus equals to value. Okay, and you can see here, if we're going south, decrease y, if we're going east, increase x, and if we're going west, decrease x. And so now we'll handle, well, we could say if CMD is equal to F, but then we'd have to check what the direction of our ship is every time. Okay, so let's handle the direction changing of the ship first. So if CMD is equal to R, we need to find a way to rotate it. But that could be a lot of if statements. So I think what I want to do here is we're going to say, so directions, we'll say north is equal to 0. North is equal to 0. And then if you imagine a compass, east is the next one on the compass. So east will be equal to 1, south will be equal to 2. And then I think we can go ahead and make west equal to 4. And it does not matter, it won't matter like what you assign these values as long as they go in order around the compass. And west should equal 3 because that's the next one. And our starting direction was east. So we're going to say dir is equal to 1. So this dir value is going to keep track of which direction we're on. And now we can go ahead and easily, I think, change the dir. So we'll say, because basically, if the degrees is 90, we want to shift right by 1. If the degrees is 180, shift by 2. And if the degrees is 270, then shift by 3. So we can do that by saying dir plus equals, because we're moving to the right, 90, value divided by 90. So if this is 270, we'll move 3 directions to the right. But for example, what if we're on s is equal to 2 and we move 3 to the right? Well, we should end up on 1 for east, but direction will actually be 5. So we can go ahead and bring it into the range of 0 to 3 by saying dir is equal to dir, I think, mod 4. And modding dir by 4 will give us an answer of 0, 1, 2, or 3. And you can see here, so if we start at s is equal to 2 and we're moving 270 degrees, then we want to end up on 1. Well, if we go 3 to the right, we end up on 3, 4, 5. And 5 modulo 4 is equal to 1, because 5 divided by 4 is 1, and then with a remainder of 1. So we would end up here. And so that works. And if, then we'll say if CMD is equal to left, same kind of logic, dir minus equals value, and then dir is equal to dir mod 4. And even if this dir goes into the negative, you can see it'll still work. So if I show you down here in the terminal, so say dir is equal to, let's say 3. Let's say dir is equal to 2. And, or actually, you know what, let's say dir is equal to 1. And we have dir minus equals 3 because we shifted 270 degrees. So now dir is equal to negative 2. But where our answer should be, because we started at 1 and we shifted 3, so we should be at positive 2. So if we take dir mod 4, you see we get positive 2. And that's because of the way modulo works with negative numbers, and outside of the scope of that video. So let's move on here. Now I think the next step I'm going to do is I'm going to turn these ifs into else ifs. And if you have a question about what I was explaining down here at the module, then drop them into the comments and I can answer you there. And so now the last case that we have to account for is the forward. So we could do an if statement down here with forward where we check each direction, again with more if statements, but I think we can just say or. So in this case, if command is equal to north, because in this case we're still going to move north. For example, if our direction is facing north. So if dir is equal to 0, because north is equal to 0, and command is equal to f. So if command is equal to f, we're going to move in the direction that the ship is facing, and if that direction is 0 or north, then y plus equals value. So now I'm going to add these in for the other 3 cases. Okay, there we go. And then so at the very end, I'll go through all the lists, change all of our numbers, and then we can say return abs x plus abs y. Hopefully that'll work, because that'll give us the Manhattan distance, and we can print get displacement. So if we go ahead and run that, oh, And we should assign xy to 0, comma 0 up top, and 9,371. Let's see how we did there. 9,371. And our answer is too high. So let's go ahead and check that everything is correct here. And I think, well, this I think is the issue right here. So we're assigning dir to 1 every single time. So let's go ahead and get rid of that and put that above the loop here. I think that should solve our issue, hopefully. You know, I always say I think, and then it never usually is, but let's just see. Okay, 923. Oh, that's considerably lower. Yeah, it says our answer is too high. What did I say? 923. So let's go ahead and check 923 out. And we gotta wait. All right, 923 again. All right, so there is the answer for part 1. Let's go ahead and move to part 2. So we realize that what the actual meanings are on the back of the instructions, and we have a waypoint, which is relative to the ship's location. So north moves the waypoint north a value, south, east, and west. Left rotates the waypoint counterclockwise, and right rotates it clockwise. And then forward will advance the ship the number of times in value towards the waypoint. Okay, so I think this will be very similar to our previous function, but just a little bit different. You know, similar but different. Super specific there. So we'll say part 2, and now we'll get def get distance with waypoint. And okay, so we'll give x comma y is equal to 0 comma 0, and that'll be the ship's location. And then I comma j will equal the is going to equal the waypoint's location, where I is the x value and j is a y value, and the waypoint starts at 10 comma 1. Okay, so waypoint starts at 10 comma 1. And I don't think we need to keep track of the direction for this one, but if we do, we'll set that up later. But for now, let's go ahead and say for line in data, once again, command and value, we can set equal to, once again, data 0 and int of data, data, and I just realized this should be line 1 to the end, and over here as well line. Otherwise we'd get we'd get not the right answer, that's for sure. And then okay, so let's go ahead and type out our cases here. So we'll say if command is equal to north, then we move the waypoint. So we want the y direction, so j plus equals to value, and I'm going to type the next 3 in. Okay, so now we can move the waypoint around, and now we're going to deal with rotating the waypoint. So let's see. So else if CMD is equal to R. So we are rotating clockwise. So we'll call our new I value I1, and I think we have to use this new I value because if we just set I directly, then when we go to calculate the new J, then it'll use the previous, or it'll use the updated I, and yeah, I don't think things are going to work. So we're going to say I1 is going to be equal to, and so if we imagine here an XY plane, a Cartesian plane, so we need our new Y value is going to be the same or our new I value, I should say, I value, which is on the x-axis, is going to be the same value as as what was on the y-axis for j. So when we're rotating right, a positive y will become a positive x, because positive x-axis will go down to the positive y-axis. So I1 is just equal to j. And then j1, that starts as an x value on the positive x, or on the x-axis, and if it rotates right, well, if it were negative, then it'll go up to positive y, and if it were positive x, it'll go down to negative y. So we can say, no matter what, it'll have the same value, but it will change its sign. So j1 times the original I, and we'll say now I and j are equal to I1 and j1. And the issue is we need to know how many times we're going to rotate. Because if it's 90 degrees, rotate once. If it's 270, rotate 3 times. So I think what we... Oops. Thank goodness for Control Z. So let's go ahead and enter that there. If we tab that over, and we're going to say while value is greater than 0. And then at the last line here, value minus equals 90. So if it's 270, that'll run 3 times, 180, that'll run 2 times, and if it's 90, then that'll run once, I think. And then else if CMD is equal to left, then while value is equal greater than 0 once again, and we'll say this time, if we're going left, then it's the I1 that'll change the sign of the j. So I1 is going to be equal to -1 times j, and the reason why that is because if it's a positive j value, it will rotate down to the negative x-axis, so giving us a negative I now. And if it's a negative j value, then it'll rotate up to the positive x-axis. So same value, but different sign each time. And then j1 is going to be equal just to I, because a positive x will rotate up to be a positive y, and a negative x will rotate down to be a negative y. So we don't need to change the sign there. And then we'll say ij is equal to I1 j1, and value minus equals 90. And I think that about covers it. So now we can just say, oh, well, we also have the case if command is equal to f. And so that will just be move x value times I. So move that towards the waypoint value amount of times. And then in the y direction, move it towards the waypoint value times j. And if I or j is negative, then it'll move in the negative direction as well. So now I think at the very end, we can return once again absx plus absy. And then if we print get distance with waypoint, let's see what we get here. It should be larger, I'm feeling. 24,769. Let's go ahead and see here. 24,769. And there you have our answer for part 2. So if you liked this video, please drop a like down below. Just a reminder that the code is available on GitHub, link in the description, and I will see you tomorrow for day 13.